Then welcome everyone. I am Gabor Sarnas, reporting in from Amsterdam, and I would like to give you a high-level overview of the LDBC benchmark suite. And as it was already mentioned today, the inspiration for LDBC's benchmarks is from the TPC benchmarks. So the TPC is another nonprofit founded in the 1980s. It stands for the Transaction Processing Performance Council, and they do benchmark specifications along with a stringent auditing process, certification for auditors. And as you can see, they have many members, many prominent hardware and software vendors. And over the years, they have produced a number of influential benchmarks like TPCC for transactional processing and TPCH and TPCDS for analytical processing. And here's a very nice chart of what they have achieved. This is TPCH, version number 2 on the scale factor 1000 dataset. The horizontal axis is time, and the vertical axis is a logarithmic scale of the throughput. And what you can see is that roughly 20 years have passed, and the throughput has increased over 1000x in these 20 years. So systems have gotten 1,000 times faster, and if you factor in the innovation in both hardware and software, then the price to performance ratio, the bang for your buck, is even more. So you can run more queries cheaper thanks to the advancements of hardware, and TPCH makes sure you can track this progress over time. So LDBC's benchmarks are quite similar to TPC's benchmarks in a number of aspects. First, they are mostly macro and application level benchmarks. So they simulate something that's an end-to-end system with complex reads, updates, and so on. We use the term scale factor. When we say something is scale factor 30, we mean that in uncompressed CSV format, it's 30 gigabytes. We allow a flexible hardware and software setup. So if you want to use GPUs, that's great. If you want to use an obscure Linux distribution, that's also fine. We can allow this, and we can accommodate this in the auditing process. Speaking of the auditing process, we also have an examination program for auditors, and we certify auditors to conduct TPC benchmarks. The auditors conduct their benchmarks, and they produce something called an FDR. This is a lengthy document that stands for the full disclosure report. It has all the metrics, like the throughput at a given scale factor. And finally, we acknowledge that, of course, benchmark needs to be renewed upon time. So LDBC has a benchmark approval and renewal process similarly to the TPC. So the first benchmark that LDBC has produced is the social network benchmark, which is actually a suite of a number of benchmarks. Let's see how this benchmark looks like through its dataset and queries. We take a simplified dataset of the SNB. On the left, you can see a bunch of person nodes like Ada, Ben, Carl, and others. And on the right, you can see a bunch of message nodes where messages that are replies to each other form subtrees in the graph. And the two parts of this graph are connected with author edges. So what is a typical question that we can ask? We can say, for example, this query, query 9, which takes two parameters, name and day. So we start, for example, with the name set to Ben and the day set to Saturday. We then start from the person called Ben. We jump one along the nose edge. We do another hop, accumulate all these edges, and then we use the author edge to jump to the messages. And then we apply a filtering condition saying that the creation date of that message must be before the given date. So in this case, we filter for days that are before Saturday. That yields messages 1, 2, and 4, and we got our result. We can, of course, run it with different configuration. We can set the name to Finn and the date to Ved. In this case, the query actually becomes a lot simpler because we just jump from Finn to Ada, enumerate Ada's friends Ben and Carl, perform the jump to the messages, and that already satisfies the criteria of being before Wednesday, and then we finish the query. And what this simple difference is illustrating is that depending on how you select the parameters, you can have a vastly more difficulty in terms of the nodes and the edges that need to be touched on. And this is not just something that occurs in the demo. This occurs in actual simulations. So here is a simulation I did over the business intelligence workload where I just selected uniform random parameters. You can see that this yields all sorts of unstable distributions, trimodal, bimodal, lots of outliers, which makes the analysis very difficult. So what the LDBC benchmarks use is a very nice trick called parameter curation. This uses high-level statistics or so-called factors. For example, here we use the number of friends for every node. We use the number of messages per given day, and we use these to balance out the number of nodes and edges that need to be touched on for a given query. And this doesn't yield a perfect result, but as you can see on this result, it already makes the distributions much tighter and a lot more close to a normal distribution or a bell curve. So today we talked about a lot regarding GQL and CQL-PGQ, and I think this query is a nice example of why these new query languages are interesting. On the left, you can see a SQL 1992 implementation of the query. It's not completely hopeless. You can definitely read it. It's a union of two subqueries, one implementing one hop and the other implementing two hops. And then there are some filtering operations defined on it. However, in SQL-PGQ, the query is roughly half the size. It's a lot more readable because you can see that it's an acyclic two-hop query. And overall, it's just much nicer to read and write. And similarly, GQL uses the same pattern matching syntax and is maybe even a bit more concise than SQL-PGQ due to the lack of the graph table construct. So, of course, this is a database benchmark, so we don't do a static analysis. We actually have updates. For example, in this social network, people keep adding friends all the time, like Eve and Gia can become friends. And then Gia may post something until up to the message of Eve. So this will be message 6 replying to message 3. And this yields an insertion of a node and two edges. Now, deletes also can occur. For example, Eve may decide to leave the social network, which will cause a ripple effect. It will not only result in Eve's node being deleted, it will also result in deleting all her outgoing author edges, nose edges, then the messages that she created, and potentially also the messages that were replies to those messages. So interestingly enough, even though this is just a simple delete, it is quite a heavy-hitting operation that we need to factor in our benchmarks. How does the benchmark framework look like? Well, overall, it just takes everything I have just explained, the data set, the updates, the parameter creation process, and runs it through a workflow. So the data gem produces the initial data sets that we use for the benchmark. The parameter generation produces the query parameter, and the driver weaves them together and validates the outcoming results. And the system under test is, of course, something that is called by the driver, and this is something that the vendors provide for the audits. So there are two SNB workloads at the moment. We have an interactive workload which does transactional processing and the business intelligence workload which does analytical processing. The interactive workload has local queries, so most queries touch one or two person nodes, and there are also short read queries which are even simpler, and insert operations that are run concurrently. And systems compete on achieving a high throughput. And I'm happy to report that we have something that's somewhat similar to TPC's results. Over the last 4 years, we had a bunch of audits for systems such as TU Graph, CreateLink, Atlas Graph, and GraphScope. And you can see that we have a roughly 25 times speed up in over 4 years. And I actually calculated the system costs. And for the system costs, we have a 71x price performance improvement. So for a given dollar, now you can get 71 times more price performance, meaning operations per second, than compared to 4 years ago. And this is exactly what we want. The other benchmark is the SNB business intelligence workload. This is a lot more recent and targets analytical workloads. These queries touch on large portions of the data. There are 20 complex reads, including a bunch of inserts and deletes. And here we allow both bulk updates and concurrence updates typically vendors go with the bulk updates because it makes it a bit easier to implement the benchmark. We have a throughput test and we have a TPC style power test where we strive to achieve low query runtime. So systems must be able to run a query individually on multiple threads so that they have a low response time. We have a bunch of audited results from Tiger Graph and TU Graph on a bunch of different scale factors, and we also have new results coming out soon. So these benchmarks are, of course, fairly involved, and we made sure that they are very easy to use as much as is possible. And by this, I mean that we create a very detailed textual specification, we write an academic paper on all the benchmarks, and we release the data generator, the pre-generated data sets, and the driver. I would like to add that here we go above what TPC does. TPC doesn't produce pre-generated data sets, and they don't really have a driver available that you can use. They have some sort of a kit, but it's more work to implement a TPC benchmark from scratch than an LDBC benchmark. We also provide reference implementations and guidelines for implementing benchmarks. We have a trademark, which was also mentioned today, so only a result produced by an auditor can be called an LDBC benchmark. And the auditing is performed by certified auditors. Auditing is a rather lengthy and expensive process. The rough estimate is $20,000 plus infrastructure cost as a start, and usually it takes multiple weeks. Another benchmark that I would like to touch upon briefly is Graphalytics. Graphalytics is an abbreviation of graph and analytics, and this targets graph algorithms. This is a macro benchmark, so there are no audits. We just have a leaderboard ranking the entries of a competition. It has overlaps with the SNB benchmark, so we have a graph that was produced by the SNB data generator, and it has 6 graph algorithms, which I will just shuffle through quickly. Breadth first search with levels, PageRank to find the most important nodes, local clustering coefficient, which finds triangles and their ratio to wedges, community detection, weakly connected components, and the classic single shortest path algorithm. We ran a Graphalytics competition in 2023. We have yet to release the leaderboard, but this is coming out soon with a blog post explaining the implementation details. It's interesting to point out that in the SNB, there are no GPU results because GPUs don't tend to work that well in graph databases at the moment. But here, the LibGrape GPU system is leading on scale factors small, medium, large, extra large, and up to 2 extra large. So I would like to conclude with a bunch of challenges that I have identified in the last couple of years for the LDBC benchmarks. And this is a list of areas where LDBC could improve in, and the list of things that LDBC benchmarks don't sufficiently cover. The first is cloud infrastructure and cloud native systems. So LDBC doesn't really have a concept of running serverless systems or a concept of elasticity. This is because we adopted TPC's pricing specification. But in practice, what this means is that all of our audits assume that if you have a cluster of 50 machines, you turn those 50 machines on and you run those 50 machines for exactly 3 years. Of course, this is not representative of how people use the cloud. People use the cloud precisely because it's elastic and you can scale it up and down. But this is not captured in the LDBC benchmark. We also require systems to use a textual specification. I think we should reconsider that and move towards binary file formats such as Parquet. We do not stress user-defined functions, and we completely miss machine learning workloads from the SNB and other benchmarks at the moment. A couple of small problems that we have, well, one is that implementing a benchmark is very time consuming. So developing a new benchmark can take 5+ person years. The SNB benchmarks took a long time to implement, and the FinBench has also been in the making for more than 3 years now. Initially, this problem stemmed from the fact that there was no standard query language, so everything had to be specified in text. With the advent of GQL and SQL PGQ, I hope this will improve a bit. And also a recurring problem that I stumble upon is it's really difficult to find a good baseline system, because the reason we are doing the benchmarks is to improve these baseline systems. But it's really hard to get like a scale factor 1000 run when the systems are not yet ready to actually implement the benchmark. For the audits, we have a bunch of audit results, but the number of declarative results is limited. So we only have one declarative implementation compared to roughly a dozen imperative implementations. And of course, users would love to have declarative implementations. This is something where I hope we can improve. I think our auditing process is quite long and expensive. So that's, of course, necessary thing to make sure that the audit is conducted very fastidiously and correctly, but this may be a frustration for vendors. And as mentioned at the end of the previous talk, we need to generate data sets for scale factor 1000, 100,000 and beyond. And the final problem I see is that while graph databases have climbed DB-Engine's ranking quite steadily for 10 years, they have started to drop off in the middle of 2022. So compared to 3 years ago, we have now a 1/4 drop in popularity, and it doesn't seem to stop anywhere. So this is not really a great sign for graph databases as a whole, and it may represent a shift to relational, or it may represent something else. This is definitely something to keep in the back of our minds. So with that, I would like to summarize. I talked about the 3 top benchmark: interactive V1, BI, and Graphalytics. There's interactive V2 under creation. There is the SPB available for audits, and the FinBench that Shipank is going to talk about. Thank you, and let's open the floor for the Q&A.
Any questions about SMB benchmark and the LDBC benchmark suite?
Hello, Gabo. I have a question about do you consider intentionally add some dirty data samples in SMB benchmark? Because I think the SMB data is so perfect. For example, one person just have one country. In this situation, the implementation maybe have some optimized where it doesn't represent the real world scenario.
So I missed the middle part of the question, but it's about the realism of the SNB dataset. Is it correct?
Yes.
Yes. So I think one of the things that we could definitely improve is that the SNB dataset is something like a third normal form classic tabular dataset. It's really missing the heterogeneity of a dataset. Like a typical knowledge graph may have hundreds of types, and this is not reflected in the SNB dataset. So that's definitely something that could and should be improved. So more types and more labels. And also other relationships, of course, could be added to this data set. I have already started thinking about DataGen v3 that would move from the current one and would be more heterogeneous and maybe more interesting with more correlations, but this is a future plan.
Can I have a question following up with other questions? So what we think is like adding some intentionally dirty data, which is like not only like perfect, make it so perfect, because like some company, they are based on the scheme, based on the format of the data, they have like special optimization for that. And we are hoping that the LDBC benchmark results can be used as a reference for a company to choose a graph database, which makes us a lot easier to compete with other companies. So that's what we proposal for that. Yeah, just
right. That's a very good idea. Of course, the big problem with this is it's very difficult to measure how a database can tackle the data cleaning process. This is somewhat subjective, depends on what skills the engineer or the data scientist performing the data cleaning has. But this is definitely something that we should do. And as a tying back to the previous question, I think spatial data should also be included, because we have people living in cities and people posting things from countries, but there isn't really any spatial aspect of the data. This is something that's definitely should be in the data set.
Yes, thank you. Yeah, thank you.